All right, here we go. Starting in about a minute. 1 minute. For those of you waiting, see if you can pull up the practice test. Practice test number one. Practice test number one. All right, here we go. I'm going to show you this instead to start off with. Share screen. Now, this is not today, but this is the week. So if you look at this right here, this is what our week looks like. We're going to do 2 days of review and we're going to take the test on Wednesday. As always, the practice tests are exactly like the real test. So you got 2 days. There is no reason you can't get an A on this test. We're going to do 2 full days of practice. You're doing nothing but hanging out at home, doing your schoolwork. Come on, let's put some effort into it. Let's get an A. We can do this. We come back next week, and I don't think this is correct. I believe Miss Moore just said that you guys won't be taking the PSAT the week that we get back. It'll be the following week. I have to make sure that that's right, but let's not worry about the week after this. Let's worry about this week. Get through Chapter 11 test into Chapter 12 stuff. But if Miss Moore, I believe she said that they're actually going to put push not PSAT but CMAS to that week after. So this actually should say CMAS, not PSAT. You guys are not high schoolers yet. And then, like I said, I think that this is actually going to move to that following week there. All right. Okay, so let's get on with today's stuff, which is getting ready for the Chapter 11 test. So I'm going to do this 2 days in a row, right? If you are solid, I mean like solid, like no tomorrow solid, you got this stuff, you're going to get an A on it. You look at the stuff, you're not even impressed by it. It's really easy. Then on tomorrow's class, then you can hang out, listen to me while you're doing the practice test. But for those of you that need help, today is the and tomorrow are the days to get your final help before the test. So I'll do this the same way. I will start this with on the right side here. We're going to write down all the formulas we need one at a time. So question number one on the practice test, question number one on the real test is to find a combination. Notice that this right here says to find a combination. So it says find the combination where you're picking two things out of 23. How many different combinations are there? So step number one, the formula for combination, right, is listed as NCR. Well, that's great. And that's what it says right there. But that's not the formula that you use to do the calculation. You break this up into NPR over RPR. That is the actual formula that we will use. This is what you're going to need for the test. So this part right here is what you need to answer this question right here. To do the combinations, it's NPR over RPR. It's been a little bit of time since we've done these, so let's do this one together. Let's see. It's basically says out of 23 objects, choose two of them and see how many combinations. So since it's a combination, we use the formula. Let's see, 23. I'm doing NPR here. 23. Find out how many permutations that is, and then divide that by this other. I wrote an R and I was supposed to write a 2. Sorry. So 23, choose 2 over 2, choose 2. And that's the formula. So all I'm doing is plugging those numbers in, and now we'll do the actual calculation. So all I did was take the box over here on the right, NPR over RPR, and wrote. Remember, N is the first number. This is your N value, and your second number is your R value. N is how many things you have to choose from. R is how many you choose. Remember, it's as easy as this. You start with the n number, and the r tells you how many numbers you need to write. So I start with 23, and I need to write 2 numbers, and I count down from 20, the counting principle. I count down from 23, so 23 times 22. That is 23, choose 2. So I start with 23, I choose 2 numbers, so 2 numbers. Over, I start with 2 and I choose 2 numbers. Well, the only 2 numbers to choose are 2. Remember, you just count down by 1 each time. So 23 choose 2 is 23 times 22. I start with 23, how many things you're choosing from, and I need 2 of them. So the first time when you choose 2, you got to choose 1. There's 23 to choose from. Now there's 1 chosen. Now there's only 22. I said that weirdly. First time you choose out of 23, there's 23 to choose from. The second time, there's only 22 to choose from. Now the only thing that's left is to do some canceling. Well, let's see. The 2 would cancel with the 22, and that would turn into 11. All right, a little bit of scratch work. Let's see, 23 times 11, 23 times 11, just a little bit of math work here. I get a 3, a 2, bring down my 0, 3, and a 2, add, and I get what, 253? And that is how many combinations. So you have 23 things to choose from, and you only choose 2 of them. There are 253 things, and there's the answer, 253. Okay. On the right side there, I'm going to leave that formula up there. And this will have all the formulas we need for the test here. And then I'm going to erase all the rest. And then we'll do another one. Won't do them all. I'll do a sample of each section here. And by the way, you're supposed to ask questions if you need to ask questions. All right, let's do this one. Hey, big capital letter C, we're doing a combination. So to do that, it's NPR over RPR. So it's 14. Where am I getting that 14 from? Remember, that is your N value. That's your N. And this is your R value. And I'm not writing fractions here. I'm just, probably should put arrows, not fractions. So that's 14, choose 3. That's my NPR over RPR. R is 3. So 3, choose 3. First number tells you the number that you start with. So I start with 14. The second number tells you how many numbers you need. I need 3 of them, starting with 14. And you count down by 1. 14 times 13 times 12. I needed 3 numbers that time. That's the R value. Over, and it's always going to go 3, 2, 1. All right, not bad. All right, anything cancel? Let's see, 3 goes into what, 12 4 times. So the 3 cancels, that 12 now becomes a 4. Doesn't really matter what you cancel with the 2. I'm going to choose the bigger number so we have smaller numbers to multiply. So that 14 can turn into a 7. So it's 7 times 13 times 4. 7 times 13 times 4. So just for brevity's sakes, I'm going to grab my calculator. This is a non-calculator test. 7 times 13 times 4 is 364. So 14 choose 3, notice a whole bunch more than the previous one. 364 possible combinations. Check my answer, 364. All right, who has questions on how to calculate combinations? All right. So I'm going to leave that formula up there for combinations. Oh, I don't want to do that. I need the eraser. And we are going to move on. Permutations, our second formula. Combinations is the harder of the two. Permutations pretty easy. Remember, I also gave you the answers. All right, so the formula for permutations, believe it or not, P for permutations is NPR. Not very different from the combinations one, but it's just NPR, just straight up NPR. Notice we're not dividing, so therefore you always get more permutations and combinations. So this one is NPR, where I already have the I'm going to use arrows instead because otherwise it looks like I'm doing fractions. So that's my N, and the 3 is my R. I plug those in. So let's see. I need to start off with 6, and I need 3 numbers. So I simply count down 3 numbers. 1, 2, 3. And remember, we're always counting down by 1, the counting principle. 6 times 5 times 4. Let's see, 6 times 5 is 30. 30 times 4 is 120. So we get 120 permutations. 120 permutations. Checking my answer there. Let me put a box around this. Actually, I don't need to put a box, but I will. Remember, N is the number you start with. R is how many numbers you're picking. And we always go down by 1 each time. So I'm starting with 6. I need 3 total numbers, 1, 2, 3. And I count down by 1, starting with 6. 6, 5, 4, and then multiply. Permutations are pretty quickly done. Now, granted, I mean, if this first number N is large, if the second number is large, you're going to get big honking numbers. Okay, I don't think I'm too mean to you on these ones, but we'll see. All right, let's pick one that's a bit more, I don't know, weird. All right, let's do number 8. This will be a bigger number. It's permutation, so this one's easier. It's already an NPR formula. So I start with 5, and I need 4 numbers. So I'm going to count down by 1 until I have 4 numbers. 5, 4. I'm not starting with 4. I'm starting with 5, 3, 2. I need 4 total numbers. 1, 2, 3, 4. And then I do that math. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So I get 120. 120. Look at that. Pretty simple. So there's your quick and down and dirty review of combinations and permutations, the first 2 formulas that we had in this chapter. As you're doing this, I would highly recommend that you, if you're not 100% sure of yourself, have the video playing in the background, do all the combination ones, do all the permutation ones, review, rewind as many times as possible. As I stated before, what you're looking at is exactly the test. I'll just change the numbers around. You're going to have questions on combinations. You're going to have questions on permutations. And of course, you can always, as always, you can have a resource card. All right, let's do something different. All right, so we're back to probability. Now remember probability, that big matrix I showed you on Friday or Thursday has lots of different things. We have your basic probability. Let's see, we have overlapping and mutually exclusive events. That's one game, one turn. And then we have one game, multiple terms. And those are your other 2 possibilities, okay? All right, let's see which one this one is. So there's 4 total, we'll write them down here on the right as well. There's 4 total formulas for one game, one turn, or one game, multiple turns, okay? All right, let's see what this one says. We got the bag game. So you got your bag, you got stuff inside the bag. The bag contains 3 yellow tickets, numbered 1 through 3, and the bag contains 5 green tickets named labeled 1 through 5. You randomly pick a ticket, so it looks like we're doing one game, one turn, one game, one turn, one game, one turn. So one game, one turn. So let's see. This is called mute, or what? We don't know yet. Let's read. It is the probability of it's yellow, or is an even number? Can those happen at the same time, or mutually exclusive? I'm sorry. Can they not happen at the same time, mutually exclusive, or are they overlapping? Well, let's see. Can you be yellow and an even number? So if you are yellow, you are labeled 1 through 3. So yeah, there is an even number there, and that's 2. So this one is going to be overlapping. I'm going to put OV for overlapping. All right, OV, overlapping events. One game, one turn. So overlapping actually, let's not do that. Let's just write the actual probability. The probability of A or B, equals the probability of A. This is overlapping events. Plus probability of B minus the overlap. And remember, minus the probability that would be both A and B happen at the same time, minus the overlap. So minus the probability of A and B. A and B. All right. This is very hard writing with my finger. All right. All right, so that is our overlap. Now notice I didn't put mutually exclusive would be, and I'll just write this one. Here's mutually exclusive. So the probability of A or B, it's the easy one. This is and I'll label here a little bit better here in a second. A or B, this is mutually exclusive. It's just simply the probability of A plus the probability of B. So this is the easy one. So one game, one turn, and both events can't happen at the same time. Probability of A plus the probability of B. Mutually exclusive versus overlapping. All right, so this is OV overlapping. This is ME mutually exclusive. Okay. So back to we're doing overlapping. So let's see. We need the probability of A. The probability of A is that it's yellow. So how many, what's the total we have here? We got 3 yellow. We have how many, bag also contains 5 green. So plus 5, that's 8 total things in the bag. So there's 8 total things in the bag. What's the probability that it's yellow? Well, there's 3 yellows. So that would be 3 out of 8. It says add to that the probability of B. The probability of B is that there's an even number. Well, let's see. For yellow, there's only one even number. That's 2. Green, labeled 1 through 5. So there would be a 2 and a 4. All right. So let's see. How many even numbers? There's 3 even numbers. There's a 2, and a 4. There's a yellow 2, a green 2, and a green 4. So once again, there's 3 out of 8 that are even. Now the overlap would be, well, what could be well, there's 1 yellow and there's 1 green that are even. So how many the overlap? Well, there's 2 that we need to subtract from, right? So let's see, we need to subtract 2 here. Minus 2 out of 8, and that's your overlap, right? That is what overlaps, and then we just simply need, hey, look, common, and it will always be this way. It'll be common denominators. 3 plus 3 is 6, minus 2 is 4. So we get 4 out of 8. In other words, we get a half. So 50-50, 50%. All right. So that is your probability that happens. Oh, I did something wrong here. What? Oh, the overlap, there's only 1 overlap. Sorry. I put 2. Remember, it's not how many things that are listed there. It's like how many overlaps do you have? So we only have 1 overlap. How did I make that mistake? So that's minus 1. Sorry about that. Minus the 1 overlap. And that would give us a 5 out of 8. There we go. Now we're correct. Make that nice and pretty. Okay, 5 out of 8. Now the question is going to be, do we need to change it to a percent? Can we leave it as a fraction? Let's leave it as a fraction. Let's leave it as a fraction. All right, questions on that one? Let's do another one. So this was the 1 game, 1 turn one. All right, let's see about number 10. There are 9 shirts in your closet. 5 are blue and 4 are green. 5 are blue and 4 are green. 2 of the blue shirts and 2 of the green shirts fit well, and the others are too big. You randomly select a shirt to wear. It is green. And what's the probability it is green and it fits well? All right, so we're back to mutually exclusive. Or, sorry, overlapping. Why? Because you can be green and fit well, because of the green shirts, 2 of the green shirts fit well. All right, so you do have some overlap. You do have some overlap. All right, so we're overlapping again. Let's do this one. So let's see. Probability of A, what's A? A is that it is green. So let's see. A is that it's green. So let's see. How many shirts in total do we have? There's 9 total, and 4 are green. So probability that's green is 4 out of 9. Probability that it fits well. Let's see. 2 of the blue and 2 of the green fit well. 2 of the blue and 2 of the green fit well. So that would be what? How many fit well? Probability of being fitting well would be 4 out of 9 as well too, because there's a total of 4. We have to subtract the overlap. The overlap, there's not one pair of even numbers, 2 and 2 last time. There's 2 this time, so minus 2 out of 9 is your overlap. Minus 2 out of 9. So there are 2 things that are both green and fit well. 2 things, right? Because it says 2 green fit well. All right, so let's do this one. This one's pretty easy. 8 minus 2 is 6, so we get 6 over 9, which reduces to what? 2/3. So 2/3. Once again, you do not need to write this as a percentage. It would be roughly 67%. All right, overlapping. Mutually exclusive are easy. It's just probability of A plus probability of B. So 2 events that cannot happen at the same time. All right, feeling a bit more confident? All right, let's do another one. Let's do another one. There's 6 nickels and 7 dimes in your pocket. 2 of the nickels and 4 of the dimes are Canadian. If you ever lived in the Northeast, right on the border of the United States and Canada, it is common occasionally for people to put the wrong coins in the wrong country. So that's, if you grew up in the South or in the West, you've probably never seen this before. You grew up in the Northeast or anywhere along the Canadian border, this is a common thing. There's 6 nickels and 7 dimes in your pocket. 2 of the nickels and 4 of the dimes are Canadian. The others are US currency. You randomly select a coin from your pocket. Is it a nickel, or what's the probability that's a nickel, or is a US currency? Or is a US currency? Can you both be a nickel? Now, this one requires you to have, I won't put one of these on a test. It requires you to know that the nickels could be both US or Canadian. So this one is once again another overlapping. So one more overlapping, we'll move on. All right, so the 2 events that it's a nickel. Let's see, there are 6 nickels and 7 dimes. 6 plus 7 is 13. So there's 13 total things. All right, what's the probability that's a nickel? There's 6 of those. Second event, is it US currency? All right, so how many US currency? 2 of the nickels and 4 of the dimes are Canadian. 2 of the nickels, so 2 plus 4 is 6. 13 minus 6 is 7. So there's 7 coins that are US currency. 7 coins that are US currency. All right, so let's see, overlapping. It says 2 of the nickels are Canadian. 2 of the nickels are Canadian. So 2 of the nickels and 4 of the dimes. So 6 total coins that are Canadian. However, for the overlap, you'd have to be a nickel and US currency. So this one's a little bit confusing. Let's see if we can tease out what we need. We need the overlapping. So how many nickels are US currency? How many nickels are US currency? And that would be the overlap. How many nickels are US currency? And it's just saying it backwards. It's saying 2 of the nickels are Canadian. So if there's a total of 6 nickels, then 4 of the nickels would be US currency. So 4 out of the nickels are US currency. And if you're a US currency and you're a nickel, you're both a nickel and US currency. So that's your overlap. So -4. Oh boy, this was a hard one, right? And the only reason is because it tells us about Canadian currency, but they ask the question about US currency. So just requires you to put your thinking cap on. 6 plus 7 is 13. 13 minus 4 is 9. So we get 9 out of 13. 9 out of 13. And like I said, you don't need to write that as a decimal. But as a decimal, what did it say? 69%. So 69%. Okay. Enough of the overlapping ones. Enough of the overlapping ones. Let's do something different. All right. Let's see. Which one is this one? This is an or. We don't want an or. We want to do something different. That's an or. Here we go. 15. All right. So this one's different. It says there are 8 nickels and 5 dimes in your pocket. You randomly pick a coin out of your pocket and then return it to your pocket. Then you randomly pick another coin. All right. So this was our last 2 formulas. Remember, this is with and without replacement. With and without replacement. So this is with replacement. So this is one game, WR, with replacement. All right. And then the other one, WO, without replacement. So this is one game, multiple turns, one game. So without or with replacement, the game resets itself. So the probability, this is an and, so the probability of A and B occurring, A and B, and notice there's literally an and here, A and B, and this is the one involving multiplication. So this was going to be the probability of A times the probability of B. So probability of A times probability of B. And since we're already here, so this is when you replace, the game just resets itself. You just multiply the 2 probabilities together. So with without, that's an O, without replacement, so the probability of A and B. This was just written weird. It's not that hard to calculate. So without replacement, I take the coin and stick it into my pocket. It's still probability of A. It's still multiplication. So it's probability of A. It's still multiplication, but this time it's just written weird. It's the probability of B, and it's got a vertical slash, given, that's what the slash means, given that A already occurred, that A already occurred. All right. So we read this carefully. It says that you randomly pick and then you return it to your pocket. So this is with replacement, with replacement. Okay. Do this real quick, with replacement, with replacement. That's kind of in the way. I randomly pick a coin. What's the probability? The first coin is a nickel. First coin is a nickel. How many nickels are there? There's 8 nickels. How many total coins? There are 13. 8 plus 5 is 13. So that's 8 out of 13. Oh, I don't know if anything's going to reduce. It's with replacement, so it's multiplying. And the second coin is a dime. Second coin is a dime. There's 5 dimes out of 13. Oh boy, there is nothing that cancels here. So we simply need to do that math. So that math would be what? 8 times 5 is 40, multiplying straight across. Well, 13 times 13, that's 13 squared. And that's what, 169? Anything go into that or no? So unfortunately, that is our answer. So 140 over 160, it says 24%. 24%. Okay, that one wasn't too bad. Let's do another one. We'll do another, unless the very next one is with replacement, and then we'll skip. First one, second one, show. All right, so this is another with replacement, because remember, dice don't change after one roll. It's the same thing. All right, so this is, once again, this is going to be with replacement because the game resets itself. So probability it shows a 1, and the second one shows a 1. So the probability that shows a 1, well, probability of a 1 is what, 1 out of 6. We've done that plenty of times. Probability it shows another 1, it's another 1 out of 6. So the probability that you roll snake eyes is what? 1 out of 36. And remember when we did that sample space, there was only one of those out of 36 things that had a 1 and a 1. So that one was pretty easy. Oops, I was meant to show the answer. 1 out of 36. So about 3%. Only about 3% chance of you rolling double ones, for those that were curious. All right, so let's do one without replacement. Let's find one that says without replacement. You random piece of chocolate. Oh, you eat it. Well, okay, this is a little bit harder to understand, but hey, if you eat the piece of chocolate, it's you no longer can pick that piece of chocolate again because it's been consumed. So this one is without replacement. All right. So let's see how we do this one. It says you got a box of chocolates containing 8 milk chocolate and 6 dark chocolate. You randomly pick a piece of chocolate and eat it, and then you randomly pick another piece. So we're picking 2. So it's 1 game, multiple turns. This is without replacement. And it says, what's the probability that both are milk chocolate? Both are milk chocolate. All right, so the box contains 8 milk chocolate, 6 dark, so there's 14 total. Well, the first time you want to choose milk chocolate, there are 8 out of the 14. But it says, what's the probability that both pieces? So when you multiply, there's no longer 8. There's only 7 left now because you ate one. So that's the probability of B. B is there's another one that's milk chocolate. But given that A already occurred, A was you picked a piece of milk chocolate and you ate it. So now there's only 7 of them left. And that's 7, not out of 14, because one has been consumed, 7 out of 13. Ooh, look, something cancels. So that turns into a 2. Life is good to us. Easy math here. So we get 8 multiplying straight across out of 26, which reduces to what? 4 out of 13. 4 out of 13. 4 out of 13 is less than 50%, but what? More than 25%. Where's my mouse? So 4 out of 13, about 31%. 31%. Okay. Like I said, that one formula usually causes some kids some problems because it looks weird. It's got a slash on it. Simply just means, given the fact that something already occurred. Usually what happens, not always, but usually what happens is things go down by 1. Not always. Just be careful. Make sure you read the question. All right. We'll do the rest as they come, and we'll see what happens here. All right, what's the next one? Oh, it's the nickels and dimes in our pocket again. You randomly pick a coin in your pocket and place it on the counter. So notice this is without replacement, without replacement, right? All right, what are we calculating the probability of? That both coins are nickels. Well, the first thing is you got to pick a nickel, right? It says that there's 7 nickels and 8 dimes. That's 15 total coins. There's 7 winners out of 15. All right, there's 7 nickels out of 15 total coins, but you pick out a nickel, right, and you put it on the counter. Now there's only 6 nickels, and there's 14 coins. All right, it's kind of just the opposite of what cancels right here. Oh, lots of things cancel here. Let me do that in blue. So that gives me a 2. 2 goes into 6. What? 3 times? No, 3 goes. No, sorry. 3 is what I wanted to reduce by. 3 goes into 6. 2 times. 3 goes into 15 5 times. There, that's better. So we've got 2/10. I'm just multiplying across. 2/10, which is 1/5. And that's what, 20%? 20% chance of you getting it. All right, that's not extremely low, right? Questions? Hey, this sounds like a pretty easy test. And yes, it will be an easy test if you are ready for it. If you're ready. The nice thing is, I gave you a bunch of examples, both this and tomorrow as well too. You should get a feeling. I mean, they can only write these questions so many different ways. All they're going to basically do is change the numbers that are attached to nickels and dimes or quarters or whatever it is they give you. But it's the same basic questions. All right, let's do another one. A cooler contains 11 bottles of sports drink. 6 are lemon lime and 5 are orange. I like the orange ones. You randomly grab a bottle and give it to your friend. Well, unless your friend immediately takes a drink and throws it back in the box, this is without replacement, right? Without replacement. All right, so it's our without replacement formula. Probability of A times probability of B, given that A occurred. There are 11 sports drinks and 6 cool things, 11 bottles. Oh, I almost made a mistake there. There's 11 total, right? 6 of them are lemon lime and 5 of them. Oh, okay, 11 total. So what's the probability that you and your friend both get a lemon and lime? So the first person who reaches in has 6 out of 11 winners. All right, so the first person picks a lemon and lime. The second person, there's only 5 left out of what, 10? Anything cancel here? Yeah, a couple things cancel. What, the 6 and the 10. So 2 goes into 6 3 times. 2 goes into 10. Oh, look at this. I got a 5 over a 5. So both of those cancel, and I'm simply left with, that's a horrible 3. 3 over 11. Ooh, double canceling. We like that. Double canceling. So 27%. All right, you guys are being awfully quiet, awfully quiet. Does anybody want to pick one to look at? Any one on the entire sheets that we have not yet done yet? Any one on the entire sheet? Somebody pick one. So these go all the way up to 21. I know I got a bunch of people online. Donovan, pick one. Nothing from Donovan. Let's
14.
do 14. All right, let's do 14. All right, it says a basket contains 5 apples and 5 peaches. 4 of the apples and 2 of the peaches are rotten. Well, I don't want any of that stuff. You pick a piece of fruit. You randomly, so it's one game and one turn. I have not written this formula down. It's one game and one thing. So this is as simple as it gets, right? That's just simply basic probability. You randomly pick a piece of fruit, right? It is one game, one turn. So it is fresh or it is a peach. All right. Can you be fresh and a peach at the same time? And the answer is, I think it's yes. So this would be overlapping. Can you be, are all the peaches rotten? Let's see. For that, 2 of the peaches are rotten and there's a total of 5. So this one is an overlapping one. 2 of the peaches. So we got 2 good ones, three fresh ones. So they're asking this one a little bit backwards as well too. They tell you how many are rotten. They don't tell you how many are fresh. All right, so we're talking about the probability of A, that it is fresh or it is a peach. So we got to figure out how many fresh things there are. We know that there's a total of 10 total things, right? 10 total things, right? 10 total things. And how many of the 10 are fresh? It says 4 rotten and 2. So 6 are rotten. That would leave 4 left that are fresh. So there's your probability of A, that it's fresh. The probability of B is it is a peach, right? The probability of B that it's a peach. Well, how many peaches are there? There are what? There are 5 peaches.
3.
That's going to be our overlap. So 5 out of 10 is how many? Because it just says what's the probability it's fresh or a peach. Okay. Now the overlap are that it's both a peach and it is fresh. So let's see. If it's a peach, then it's fresh. How many of 2 of the peaches are rotten? So 3. So that's what we're going to subtract. So we're going to subtract 3 out of the 10 that are the overlap. 3 out of 10. So 4 plus 5 is 9. 9 minus 3 is 6. So 6 out of 10 is what we're left with. All right, that's a pretty good chance that it might be. A little bit more than 50%. I'm not sure if I want to play that game. If it's rotten fruit, the rotten fruit will be touching the good fruit. So that sounds kind of unhygienic. So 2 goes into 6 3 times. So 3 out of 5 is our final answer. 3 out of 5. All right, 60%. There we go. That is your review. Now, tomorrow I'm going to do exactly the same thing. Exactly the same thing. What I would recommend, probably the hardest thing, it's not the math. The math part's pretty easy here. The hardest thing is to realize which one of these 6 formulas to use. Now, granted, if it's a combination or permutation, there's no question. I mean, it's literally going to tell you it's going to have a C or a P. But all the other ones, the overlapping, the mutually exclusive, the with replacement, the without replacement, those are the ones that you need to read. Now, I almost did every single one of them there for you. And hopefully you can understand whether it's not overlapping, mutually exclusive, or with or without replacement. So my suggestion to you is to spend the rest of the time of your study that you're going to do for math today doing this practice test at least twice, right? And none of the math is that hard that it takes you hours to do this. I would do the practice test twice, and then tomorrow you'll either know that you have a problem or you'll know that you're pretty confident. For those of you that are pretty confident, then tomorrow, if you want to show up for class, that's great. If not, you can simply print off the practice test and do it. For those of you that have problems, then tomorrow is when you should hit me up with questions, because the test is Wednesday. The test is Wednesday. But like I said, for those of you that do this one really well, then do tomorrow real well, and you'll be well prepared to do. I mean, it should be a whole bunch of A's that are on the test. Jaden, I did get your comment right there. I do have a bunch of no-name files or no-name homework that was turned in last week. Maybe yours is one of the no-name, but no, I have not gotten anything with your name on it for those homework assignments that you're missing. All right, last call for questions. Last call for questions. As always, for e-learning, it always ends up being a little bit quicker than it is in person. But it is what it is. We're finishing, what, about 5 minutes, 7 minutes, a little bit early. But we'll end it right there. You guys have a wonderful day. If you do have any questions, hit me up in chat or an email. But if not, then I will see you guys tomorrow.